Hello all. Today we are solving LeetCode problem number 3047. Find the largest area of square inside two rectangles. So we are given n rectangles in 2D plane, and these rectangles are parallel to both x and y axis, and we are given a 2D integer array which is bottom and top, right? So where we have bottom of I has AI and BI as the coordinates, right? And top of right also has CI and DI as the coordinates. So what exactly this mean? So if you see a 2D plane, and for rectangles we need 2 points, right? So in the previous sums for squares we just need 2 points and the distance, but for rectangle we need 2 point, which is bottom left point and top right point, right? So using which you can construct a rectangle. So that is the reason they are giving these 2 points to construct a rectangle, right? So we need to return the maximum area formed by at least the intersection of two rectangles. So we have to consider at least two rectangles. If there is given n rectangles, we have to consider at least two rectangles, and we have to return the maximum area uh, maximum area of squares formed in this intersection. So if this is a rectangle, then this could be a square, right? This area, this could be a square, and this could be a maximum square. So that is what you have to return. So if you are not able to find a square, you have to return 0. So that is it about this problem. So let us go through the first example for better understanding. So we have three rectangles given, which is 1, 2 and 3. So we need to find the intersection between at least two rectangles, right? So for processing it, we can process by rectangles 1 and 2 at a time, right? So first iteration we can process 1 and 2, and second iteration this can be um, 1 and 3. There is no intersection here, so this will not be possible. And next, that can be in the third iteration, this can be 2 and 3, and there is intersection, so this can be possible. And this is how we iterate, and we consider two rectangles at a time, and then we process it, right? So clearly you can see the intersection area. So this is the intersection area available. So you can see that this is not a proper shape, and we can see here this forms a rectangle, right? So this particular area forms a rectangle, right? And you can also see there we can also form square here by dividing this. There is three squares, 1, 2 and 3, right? And among all these three squares of are in area 3, I mean area 1 respectively, all three of the squares. So maximum among 3 will be 1. So that is what exactly we are returning as the output. So how can we solve? uh, let me Before solving that, let me consider two shapes so that we can find the intersection points, and then we can process it. So how do we solve, right? So we can consider two shapes, two rectangles, right? And this can be one more rectangle, right? So first we have to find the intersection points or shape. Then only we from that shape we can extract a square, and then we can find the maximum area which could be formed out of the shape, right? Maximum area of a square. So we need to find the intersection of of the shape, actually. I mean intersection or rectangle from the two given squares. So how can we do that? right? So here we have to work by the band the length, right? The band, top band and bottom band, we have left and right, sorry, right and left band as well. So to find the intersection we have to find the length. So how do we compare it? So we compare the, let this be shape 1 and shape 2. So we have to check the length of the left band is less than the right band, I'm sorry, the right band of shape 1, right? So which is left of shape 2 is less than right of shape 2, right? And now, oops, oops, yeah. So now next thing you have to consider is this one and this one, right? So the top of this is the top of shape 1 and the bottom of shape 2. So the bottom of shape 2 should be less than top of shape 1. So this is 1, right? And we can we from this we can come to a conclusion that this is what we have to do. And there is one more observation you need to take care of it, because we may not know what shape is a smaller rectangle and which one is a bigger rectangle, which means this is not sorted and this is not sorted. So in that case, because of that, we have to have a one more comparison, because this, suppose if this is a smaller rectangle and this is a bigger one, this can be like shape 2 and shape 1. So because of that, we have to have let me change my color. This should be and right. So yeah, so and we have to have one more comparison, which is this shape, I mean this side, which is the right side of shape 1 here and left side of shape 2 here, right? So this should be left of shape 1 should be less than right of shape 2, and similarly the top and bottom as well, right? So we do not pick green, this and this, right? So now again bottom of shape 1 should be less than top of shape 2. So if this is true, right, if this condition and this condition is true, we can say that we found intersection is true, right? Now you have to find the area of the maximum area of the square from this intersection, right? So now the question is, how can we find it, right? So for that you have to find the coordinates value. If I is equal to true, how max area, find coordinates, because using that we could able to find the side, and using that side you can square it and we can find the area, right? So because of that you have to find the left coordinate. For the left one, you have to find the maximum of this maximum of the left band of the shape 2, and maximum of left side of the shape 1. So these two maximum, I don't have any much color, yeah, so maybe I can mark it. So maximum of these two sides, which is max of what do we call this, left of side 2 and left of side, sorry, shape 1, right? And similarly for right range, this should be minimum of this side, right side of the shape 2 and right side of the shape 1. So will be, this is for left, right should be minimum of uh, right of shape 2 and right of shape 1, right? And similarly for the top and bottom also, this should be the bottom should be maximum and the top should be minimum. So based on that, we have top should be minimum, so minimum of top of shape 2 and shape 1, and this should be maximum of shape 2 and shape 1. So right, so we will be getting a value, and now we have left to right range, right? And we have the top to bottom range as well. So now to find the side, right, so we have to find the minimum among these two. So minimum, I mean minimum of this one and minimum of this one, you get the side value and you square it and then return it, right? So minimum of this range and minimum of this range, you get the side, right? And return side square. So this is the answer, right? So this is how we have to solve this problem. So with this observation, let us go ahead and code this out, right? So, and we need length, n is equal to length of, since the bottom left and top left have same the value number of rectangles value, this the both length could be same. So because of that, we can have just a single length, because that is what we are iterating to process this up. So oops, bottom left, right? So now we need a result value, because we have to return 0 if there is no possible intersection points, right? So because of that, we are storing the result value as 0 first, initializing it with 0. So for I in range n, and for j in range, this should start from I plus 1, because we are processing two rectangle at a time till range, right? So now we need the sides, which is yes L1, and this is bottom, right? So, or yeah, maybe I can rename the variable based on the the vertices, sorry, the coordinates, because x coordinate and y coordinate. So because of that, x L1 and y B1, which is left side of shape 1 and bottom of shape 2, is equal to bottom left of I, right? And similarly for shape 2, xl2 and yb2 is equal to bottom left of j. This should be j, because the next rectangle is what exactly we are processing. So now we have again xl2 for shape 2, right? So no, this should be for shape 1, we need the right side, right? So x r1 and y yb1, oh sorry, this should be a bottom and top T1. My bad, I'm a little bit confused here, so because of the naming. Right, top right of I, and this should be XR2 and Y T2, right? Yes, T2 and top right of J. So now we got the value, and now what we have to do is we have to have the comparison to find the intersection comparison, right? I mean find the intersection by length comparison. So if that is true, then only we will be able to proceed further. So first one, that is left side of shape 2 compared with the right side of shape 1, right? So that is XL2 is compared less than XR1, and X left of 1, yeah, this should be, and XR2, yeah, and this should be compared with, and this should be with Y B1, YB1. Let me check in the notes. So this should be, oops, it should be B2. It should be B2, and YL T1 top, right? It should be compared with the top, and YB1 should be less than YT2, right? So let me close this as well. And if this is true, now we have to find the left side and right side and top and bottom. So left side is equal to max of the comparison we have to do, and right side is equal to minimum, and top is minimum and bottom is maximum. So this should be side the left of shape 1 and left of shape 2, right? So XL1 and XL2, and this is XR1 and XR2, XR1 and XR2, and this should be YT1 and YT2, and finally this should be YB1 and YB2, right? So yeah, so now you have to find the result value, right? Because result is equal to, now we have to find the maximum square. So max of, you have already the existing result as a result of the previous iteration, so you have to compare with that, because each iteration, each intersection of different shapes may result in a different intersection area, which may result in a bigger square. If there is an area, there might be a chance of bigger square appearing, so because of that we have to compare it. So now it should be minimum of R minus L, that is the range, and this should be R minus L, and we have to compare with the top minus bottom, right? Top to bottom range. So that is what we have to cover, right? And this value should be multiplied, or this should be powered by 3, right? So yeah, so this should be powered 2, I'm sorry, this should be powered by 2, which is the area. So here we are finding the area. To be clear, I think we can copy this, and but I did not initialize any variable there, right? So yeah, better let this be here, it's clear, right? So now go ahead and return the result. Yes, and this is an efficient solution. Thank you.